Are you ready to delve into the world of practical biology investigations? This presentation will guide you through the essential steps of conducting a scientific investigation, discover how to collect data, analyze results, and draw meaningful conclusions. The unit focuses on carrying out a practical investigation in biology. It involves collecting experimental data and analyzing the results. The goal is to draw scientific conclusions from the data. Evaluating the strengths and limitations of the investigation is crucial. This unit is graded, offering a pass, merit, or distinction. The assignment aims to carry out a practical biological investigation. Collecting appropriate experimental data is essential. Analyzing the results helps in drawing scientific conclusions. Evaluating the investigation's strengths and limitations is necessary. The ultimate goal is to produce a comprehensive report. The task involves conducting a practical investigation based on a plan. Collecting suitable data values is crucial to test the hypothesis. Safety procedures and risk assessments must be followed. Analyzing results and drawing conclusions is part of the process. A written report explaining the investigation is required. The investigation may follow a pre-developed plan. Alternatively, a tutor-approved plan can be used. The aim is to test a clear hypothesis. Data collection should be appropriate for the investigation's aim. Planning is crucial for a successful investigation. Follow the agreed experimental methodology carefully. Accurate and reliable data collection is essential. Safety procedures and risk assessments are mandatory. Document any deviations from the original plan. Discuss changes with the tutor before implementation. Gather sufficient data to test the hypothesis effectively. Record results carefully during the experiment. Ensure measurements are accurate to maintain reliability. Use appropriate scientific equipment for data collection. Maintain organized records of results for analysis. Present results in clear tables, graphs, or charts. Look for trends or patterns in the data collected. Use appropriate biological knowledge to interpret results. Compare results with expected outcomes to draw conclusions. Identify possible errors in measurements for accuracy. Link conclusions to the original aim of the investigation. Discuss whether the hypothesis was supported by the results. Explain the biological meaning of the findings clearly. Relate conclusions to relevant scientific theory. This helps in understanding the investigation's impact. Identify limitations of the investigation for improvement. Consider the reliability and accuracy of the data collected. Discuss possible sources of experimental error. Suggest improvements for future investigations. This evaluation helps in refining future methodologies. Consider improvements to the experimental design. Suggest ways to collect more accurate data in future. Recommend additional trials or larger sample sizes. Consider alternative methods that may improve reliability. These improvements enhance the investigation's effectiveness. The report should start with an introduction and hypothesis. The methodology section explains how the investigation was carried out. Results are presented using data tables, graphs, and observations. The discussion interprets the results obtained. Conclusion summarizes the findings, and evaluation discusses limitations. Use clear scientific terminology throughout the report. Include graphs and diagrams where appropriate for clarity. Present data logically and clearly for easy understanding. Ensure written communication is accurate and well-structured. This enhances the report's professionalism and readability. Use credible scientific sources where relevant in the report. Include in-text citations where sources are used. Use Harvard referencing style for consistency. Provide a full reference list at the end of the report. Proper referencing enhances the report's credibility. A pass requires the investigation to be carried out and results reported clearly. A merit demands strong analysis and interpretation of results. Distinction requires detailed evaluation and scientific reasoning. Work should demonstrate scientific understanding and accuracy. Meeting these expectations is crucial for success. Each assignment permits one formal submission only. If criteria are not met, one resubmission may be allowed for a pass. Resubmission cannot be used to improve grades further. Tutors cannot review multiple drafts or provide pre-marking. Submitted work must represent independent academic performance. Attend tutorials and ask targeted questions for clarity. Seek clarification on command verbs such as analyze or evaluate. Ask for guidance on report, structure, and referencing. Engage with academic support before submission deadlines. This support can significantly enhance your performance. Following safety procedures is crucial during the investigation. Risk assessments help in identifying potential hazards. Ensure all safety measures are in place before starting. This ensures a safe and successful investigation. Safety should always be a top priority. Accurate data collection is essential for reliable results. Use precise scientific equipment for measurements. Maintain organized records to avoid data loss. Discuss any discrepancies with the tutor for clarity. Accuracy ensures the investigation's credibility and success. A well-thought-out experimental design is key to success. Consider all variables that may affect the outcome. Plan the methodology to ensure reliability and accuracy. Discuss the design with the tutor for approval. A solid design forms the foundation of a successful investigation. You've learned how to conduct a comprehensive biology investigation. By collecting data, analyzing results, and drawing conclusions, you can achieve success. Remember, safety and accuracy are key components.